Let's take a look at some sample problems on 13.1, the time value of money. And we'll be working from the textbook starting on page 698. If you have an online textbook, you may want to print these 2 pages, or 3 pages rather, out. Right, I do go over to page 700. 3 pages out before you watch this. But let's take a look at the first problem, which is number 4. It says, in the following exercises, assume whenever appropriate that unless otherwise known, there are 12 months per year, 30 days per month, and 365 days per year. Okay, so we're to find the simple interest owed for each loan. And in number 4, we're doing simple interest. So the first thing, write down the formula. Our principal is $5,400 at 7%, so that's 0.07. And our time needs to be in years, so we have 4 months. So our time is 4 out of 12, so that's going to be 1/3 of a year. So our interest is $5,400 times our rate times our time. So again, I'm going to use my calculator to keep from making careless mistakes. 5,400 times 0.07 times 1 divided by 3. Enter. Okay, I'm getting $126 interest. Okay, so that wasn't too bad. And the next one says, find the future value of each deposit if the account pays simple interest and interest compounded annually. So let's take a look at number 10. We're using 2 formulas here. Let's see, we want the future value. Whoops. So A equals P times 1 plus RT. That's if we use simple interest. And A equals P times 1 plus R divided by M raised to the N. So those are our 2 formulas. So let's take a look at, we have P is 3,000. Okay, rate is 0.05. Time in years is 4. Okay, so M is annually, so once a year, and N would be 4. There are 4 periods since it's 4 years. So let's do simple interest first. A equals 3,000 times 1 plus 0.04. Oops, 0.05. Let's get the right one there. 0.05 times 4. Make that a square bracket. Okay, so I'm going to start in the parentheses. 1 plus 0.05 times 4 equals, and then times 3,000. And I get $3,600. That's part A. Okay, let's go to the second formula. I'm using that one here. Okay, so in part B, A equals 3,000 times 1 plus, and we're going to take our rate, 0.05, and divide it by 1, so that's going to be a 0.05 raised to the 4th power. So I'm going to take 1 plus 0.05, So that's going to be 1.05 raised to the fourth equals, and then times the 3,000. So you get 3,646.52. So you make a little bit more money that way. Okay. 646.52. Okay, that checks out. All right, in number 14, simple interest on a tax overpayment. Paul Lewis is owed $530 by the IRS for overpayment of last year's taxes. The IRS will repay the amount at 4% simple interest. Find the total amount Paul will receive if the interest is paid for 8 months. So it's simple interest. So P, the amount they owe him is $530. The rate they pay is 4%. The time is 8 months, so that's 8 out of 12. Remember, we want our time in terms of a year. 4 would go 2, 3. So we want our amount that they're going to pay. So that's the future value. So this is the formula we want. Although you could calculate the interest and then add it to the principal to come up with the answer. Okay, 2/3. Make it a square bracket. Okay, so I'm starting with the square brackets. 1 plus 0.04 times 2 divided by 3 equals times 530, and I get 544.13. So that's what the IRS would pay him. 544.13. Okay, and number 20, we're looking at a table, and it says find the missing final amount, which is the future value and or the interest earned. Okay, so we have 3450, rate is 2.4%, it's compounded semi-annually over a time period of 10 years. We want to know the final amount, and we want to know the amount of the compound interest. So what we're going to do is we're going to use our future value formula first, and then we'll figure out how much of that is compound interest. Okay, so first thing you want to do is figure out all of the variable values. Principal is 3450. Rate is 2.4%, so that's 0.024. Don't let the 0.4 in there mess you up. You still want to change it to a decimal. Semi-annually means M is twice a year. And your time is 2, so N would be twice a year times 10 years. It's going to be 20 payments, or 20 times it's compounded, I should say. So A equals 3450. 1 plus 0.024 divided by 2 raised to the 20th. I think I'll do a little arithmetic in my head here. 0.024 divided by 2 is 0.012. So I can do that addition in my head. So 3450 times 1.012 raised to the 20th. And I'm getting 4379.55. So that's my first number, and I need to subtract the 3450 from it to figure out the interest. So notice we're figuring out the future value first, and then we figure out the interest by subtracting the original principal from it. And it looks like the interest is $929.55. So we have two answers for number 20. Okay, so let's turn the page, and okay, we have some problems dealing with estimating the years to double by the rule of 70, and I didn't go over this in the lecture, but basically what you're doing is you're taking 70 and dividing it by the annual inflation rate. So that's why it's called the rule of 70. So let's choose one of these. Let's look at 56. Okay, the rule of 70 says what we do is we divide by the inflation rate, and they give us the inflation rate as 8%. So what I want to do is divide, and we're supposed to use my boo-boo here, 8%. So we want to take our 70, let me clear my calculator, and divide it by 8, and we don't change it to a decimal this time, and it's 8.75, so we're going to round that to the nearest whole number. It would take approximately 9 years to double. Okay, and the next group, they reverse it. They're still using the same formula. Let's look at number 60. What they give us is the years. What we don't know is the inflation rate, so we'll call that X. If I multiply both sides by X, I get 70 equals 16X. Divide by 16. 70 divided by 16 is 4.375, so we'll round that to the nearest tenth of a percent, would be 4.4%. Okay, so those weren't too bad. I just wanted to mention the rule of 70 since I didn't in the lecture. It is a fairly simple thing to apply. Now, our next group is where we have an item and we're talking about a period over which the inflation rate is remaining constant, and we're given a 2010 price for the item, and we're to figure out what the 2015 price will be if inflation rate is 2%. 2025 price if, again, inflation rate is 2%. 2015 price if the inflation rate is 10%, and then the 2025 price if the inflation rate is 10%. So I thought we'd go with a gallon of gas. So let's look at number 60.